theory part of triple integration. See, triple integration, actually it is same as a Riemann integration. If you remember what we do in Riemann integration, we find partition, we take supremum, infimum, upper sum, lower sum, upper integral, lower integral. If both of them are same, we declare it is Riemann integrable. So see, same thing we have here, just we simply generalize those concept, nothing else. Okay, see here we have a bounded function f, you can see here, and which is defined on this cuboid, okay, which is as a product of AB cross CD cross EF. So that means length, breadth and height, same relation we have. First of all, what will I do? I will take a partition of that cuboid. For that purpose, I will take partition of AB, partition of CD and partition of EF. So let us take. Let P1 is equal to A is equal to x0, x1 and so on, xn is equal to B. Be partition of closed interval AB. Similarly, I will take partition of CD. Let P2 is equal to C is equal to y0, y1 and so on, yn is equal to D. Be partition of closed interval CD. Let P3 is equal to E is equal to Z0, Z1 and so on, Zp is equal to F. Be partition of closed interval EF. So that means we have taken partition of AB first, right? After that we took partition of CF. After that we took partition of A, B, C, D and EF. In this way we took partition. Okay, so we will take product of all partitions. So we will have an actual partition of that cuboid. So then P is equal to P1 cross P2 cross P3 be partition of S. Okay, having M and P subcuboids. Okay, M and P subcuboids. See what is happening, I will show you. Because of partition of AB, we will have a slice like this, we have a layers like this. Okay, so because of this partition, that cuboid will be divided into these layers. Because of this partition, see, because of this partition, what will happen? We will have a layers like this, getting, and because of this partition, it will be divided into this part. So that means, just a minute, I will show you here. Okay, so actually the main cube is divided, this cuboid is divided into M and P subcuboids, and each of them have some certain volume. I will call it as delta Ijk. Okay, with volume, I will mention with volume delta Ijk. See, after that, you remember after taking partition, obviously we go for that supremum and infimum. The function will have supremum value at some point and function will have minimum value over each cuboid. So this is possible because f is a bounded function. Here f is bounded. This is very important thing, that's why it is possible, bounded. So let what I'm going to do, capital Mij, I running from 1 to n, you are getting now. So how many partitions are there? N. I running from 1 to n, j running from 1 to m, and k, sorry, 0 to 1 to m, and k running from 1 to p. So capital Mij is equal to supremum of f of x, y, z such that x varies from xi minus 1 to xi, y varies from yj minus 1 to yj, and z varies from zk minus 1 to zk. It is same as Riemann integral. We do the same thing in case of Riemann integral, getting? So see, over each cuboid function will have either minimum value or maximum value. So that value we are going to find here. Okay, so it is just like this. if you consider all students of your college, there are partitions for arts, commerce and science. So that's why all students of college, okay, are divided into these three categories: arts, commerce and science. So if you consider these are vertical categories, so we have simultaneously horizontal categories also: first year student, second year student, third year student. So that's why, because of these three partitions, vertical partitions, and these three horizontal partitions, entire all students of college are divided into total 9 classes. That means first year arts, first year commerce, first year science, second year arts, second year commerce, second year science, in that way. Getting? So that's why I could write this. Next, small mij, which is equal to infimum. Here we take supremum, here I will take infimum. F of xyz having a same thing. Okay, simply copy. Next, I will go for upper sum. Okay, then upper sum is, you remember upper sum, UPF is equal to capital Mij delta Ijk. Actually we take summation here, but see, we have three variables I, j, k, so that's why I need to take three summations. Summation, one for I, second for j, and third for k. Yes, so UPF we have got. Similarly, I will go for LPF also, but there is no more space. So I suggest you to make a screenshot of it. After that, we will go further. See, now we will take lower sum. Now, lower sum is LPF, which is equal to, here we take summation small mij delta ijk. Okay, but see, three variables are there, so I will take three summations: one for I, second for j, and third for k. Right? See, UPF and LPF have some values, but if you change the partition, we will have different values. So what we do, upper sums, that means for each partition you will have upper sum. For P1 you will have some upper sum, for P2, for P3, for P4. So we will take infimum, that means smallest upper sum. Okay, that is, we call it as a upper integral. Then upper integral will be UF, which is infimum of UPF. Okay, infimum of UPF, where P is partition of S. Getting? So we take a smallest upper sum, so that is our upper integral, and lower integral means supremum of LPF. Okay, so we will take a supremum. So then and lower integral is LF is equal to supremum of LPF, where P is partition of F. What is the relation between them? Always, clearly I can write, always lower integral is less than or equal to upper integral. Okay, so there is a very small difference, but lower integral is always less than or equal to upper integral, and we can have equality also. When we get equality for any function, then we say the function is Riemann integrable, or here we say the function is simply triple integrable. Okay, so see, if LF, that means lower integral, is equal to UF, then F is said to be integrable. Okay, integrable, and the lower integral, which is equal to upper integral, and which is nothing but actual integral of F over S. So this thing we get. This is the actual definition of integrable when we say the function is triple integrable. Okay, see, after that I will continue this theory. What will I do? We have divided that cuboid into some small cuboids, but right now what will I do? I will consider an entire cuboid. Okay, so what I'm going to do, let capital M is equal to supremum of f of xyz where xyz be any arbitrary element of S. That means over entire cube. Okay, I'm considering this, that it's not cuboid. For entire cuboid, what I'm considering its supremum function of f. Okay, f, and small f will be infimum of f over entire cuboid. Okay, so for xyz belongs to S. So what will be the relation? What will be the relation? Here m is a supremum over entire cuboid, okay, and small m be the infimum over entire cuboid. It is just like this. If the exam result is declared, okay, entire college, some student will possess a first rank, getting, that means having a highest mark, and in the entire college there will be a student having lowest mark, getting. But in each class wise also we can have a topper and lowest marks, getting. So what will be the relation between these two for these values? Clearly we can write clearly one thing, that means capital M, it is a supremum over entire cuboid, no? So that's why it will have a maximum value, and small m, it is a infimum over entire cuboid, so that's why it will have minimum value. And this is, so capital small mijk and capital Mijk will lie between them. Okay, so yeah, it is true for all Ijk, huh? For all I running from 1 to n, j running from 1 to m, and k running from 1 to p. It is true for all. Okay, you can make a screenshot of it. After that we will go further. See, we will multiply all sides by delta Ijk. See what will happen then. So therefore small m delta Ijk less than or equal to Mij into delta Ijk less than or equal to capital Mij into delta Ijk and capital M into delta Ijk. After that, I will take summation of all sides. I will simply say summations. Taking summations. I will take all summations for I, for j, and for k. So see, summation m delta Ijk less than or equal to summation small Mij delta Ijk less than or equal to summation capital Mij delta Ijk and less than or equal to summation capital M delta Ijk. See, it is not required. I will remove it. I will remove it. See, after that, actually summation limits, I running from 1 to n, j running from 1 to m, and k running from 1 to p. I'm not writing for remaining, but it is, you need to consider, you'll have the same limits. See, here small m is a constant, will come outside. That means it is independent on Ijk. So small m will come outside. We will have summation delta Ijk less than or equal to. You are familiar with that. This is lower sum LPF less than or equal to. This is upper sum UPF and less than or equal to. Here capital M is independent on Ijk, so it will come outside all summations. So capital M summation delta Ijk. See what we are doing actually. We are taking here delta Ijk means volume of each cuboid, subcuboid, and we are taking sum of all cuboids. That means we will have the volume of a large given cuboid. Getting? So how to find volume of any cuboid? Length into breadth into height. Getting? So length is b minus a, width is d minus c, and height is f minus c. So if you take product, we will have the volume. So therefore m here b minus a, d minus c, and f minus e. So less than or equal to LPF less than or equal to UPF, and same thing, same logic I am applying here. This is b minus a, d minus c, and f minus e. Sorry, e minus f I need to write. f minus e. After that, just a minute, we have a space here, we can use it. Therefore, m b minus a d minus c f minus e less than or equal to LPF, less than or equal to LPF, which is less than lower integral. Agree with me? Lower integral means supremum of all lower sums. Getting this is lower integral, right? Which is always, this is supremum of all lower sums. So that's why obviously it is greater or equal to other all lower sums. Lower integral is less than or equal to upper integral, and upper integral is infimum of UPF. So that's why it is infimum of all. So that's why it is less than or equal to. Get it? For example, if you consider height, so if you consider a tallest student of your class, so its height will be greater than its supremum now, so its height will be greater than or equal to other students of class. And if you consider a smallest student in your class, then his or her height will be less than or equal to height of other students of class. So same logic I am applying here. UPF is less than or equal to what? Less than or equal to capital M b minus a d minus c f minus e. So many things we have: a less than b, b less than c, c less than d, d less than e, e less than f. So the unnecessary terms I will drop and I will write inequality. So it will be like this: m b minus a d minus c f minus e less than, it is not required, I will drop it, lf less than or equal to uf. Again it is not required, I will drop it, less than or equal to m b minus a d minus c f minus e. Okay, so therefore see, actual integral, okay, but I will mention, but actual integral is always lies between lower integral and upper integral. Okay, upper integral. Actual integral always like when both of them are equal, so we will have all of them are equal. Upper integral is equal to lower integral is equal to actual integral. Otherwise, okay, in general we have actual integral always lies between lower integral and upper integral. So I will insert here. So what will you have? Then m b minus a into d minus c into f minus e less than or equal to LF, but LF is less than or equal to actual integral of f over s. Actual integral is less than or equal to UF, and UF is less than or equal to m b minus a d minus c into f minus e. So in this way we have actually covered a very important result here, proof of very important result. So see, you can make a screenshot of it and after that we will stop. Thank you. Bye bye.